Hello everyone, my name is Maureen Hayden from Texas A&M University, and one thing I want you all to do for a moment is take a step back and think about, in the past week, anytime you've used one of the following items: a straw, a plastic grocery bag, maybe some takeaway containers and plastic utensils the last time you ordered out because of the pandemic, maybe a plastic drinking bottle or a coffee cup. And so with all of these convenience items, one thing they all have in common is that they are made from plastics. And I'm sure it may come as no surprise to you that plastics are a hot topic when it comes to climate change and the impact they are having on our environment. Specifically, when it comes to marine life, plastics can have several effects, such as the first thing we usually think about is accumulation in the gut. So this is when plastics will be in the gut but not actually stay in the gut, they'll pass through. So this can lead to retention in the gut. Other things is some past studies have shown absorption of contaminants from the environment through the consumption of plastics, and sometimes these plastics can even be translocated to other organs. This can also alter animals' behavior by leading them to think that they're full, or false satiation, leading animals to potentially not eat as much. And then additionally, this can lead to overall behavior changes and lower survival rates among marine fauna. Two really popular examples of ingestion of plastics in the marine environment are the Midway Atoll with the albatross, and then also sea turtles ingesting plastic particles. So while these are charismatic megafauna and what we usually think of, right, whales, turtles, seabirds, and fish, when it comes to plastic ingestion, we also need to take a look at lower trophic levels, such as invertebrates. So specifically, my project is focused on beaches and lower trophic levels, or beach fauna. And here on the Texas coast, in the Gulf of Mexico, I'm specifically interested in these tiny little costeroid amphipods. Now these guys are typically range in size anywhere from half a centimeter to about a centimeter and a half. They live in the sand, and so they live in the swash zone, where they will stay moist, but they usually bury down during the day. And they're a common food source for a lot of predators. If you look in that red circle and watch, you can see them swimming away now. And again, like I said, typically to avoid predators, they can swim a little bit, but they'll spend most of their time buried in the sand, just like that. And so to know if these interstitial fauna or small amphipods are at risk of plastics, we need to first ask ourselves, are there plastics in their environment, and what are plastics? So microplastics specifically are defined as small plastic pieces that are less than 5 millimeters in length, so that's about half a centimeter, or the size of a frozen baby. So here are some photographs of microplastics. So on the left hand side you can see some plastics in my hand, and then specifically on the right hand side we have what's called a nurdle, which are plastics that are used for manufacturing, but you can also get microplastics through the breakdown or degradation of larger particles into these smaller fragments, which you can see in the center image here. Additionally, plastics can break down into even smaller size categories known as nanoplastics, and these can be less than 1 millimeter in size, and I have highlighted these outlined in red on the images below. So as I mentioned a little bit earlier, in order to know if these amphipods are at risk, we first need to know, do microplastics occur on sandy beaches where these amphipods are found? And that was the goal of this study. So we looked at this question on 3 Texas state park beaches over the course of 9 months. And for this study, we picked a range of beaches that covered a good span of the 400-mile Texas coastline, all the way from Sea State Park, which is in northern Texas, the popular Galveston Island State Park, down further south to Mustang Island State Park. For this study, we sampled during the summer of 2019, the fall of 2019, and then also the winter of 2020. We also ran, and then what we would do is we would run transects parallel to the shore at high tide line, and we would sample a 50 by 1 meter area. And on the surface of those transects, we would just pick up whatever we would find and then bring it back to the lab for processing later. Once back at the lab, we would take what we found in each transect and we would individually catalog each piece of debris or each microplastic using a camera pen attached to the ocular lens of a dissecting microscope. And then we would take note of certain characteristics. So for example, we would categorize our type of microplastic that we found. So a plastic particle, whether it was a fiber or a nurdle. So a nurdle is characterized as a primary microplastic. They are specifically spherical in shape. We would take note of its size, and we'd also take note of the particle's color. To give you an idea of how these categories played out, in the upper left-hand corner is a nurdle. In the upper right-hand corner is a nanoplastic. In the lower left-hand corner, in the lower left-hand corner is a secondary microplastic, and then in the lower right-hand corner is a fiber. So what did we find after sampling 3 beaches once in 3 different sample seasons? Summer, fall, and winter. Firstly, we found that Galveston Island State Park had significantly more microplastics collected for all 3 sample seasons when compared to both Mustang Island and Sea State Park. And then furthermore, we found that plastic particles, shown here in dark navy blue, were the greatest category of materials collected at all 3 sample sites for all 3 sample seasons. Furthermore, if we break this down and look at Galveston Island State Park specifically, there were significantly more plastic particles, shown in dark blue, than fibers, shown in light blue, during all 3 sample seasons. And then finally, since plastic particles were so prevalent at each of our sample sites, we found that there were significantly more plastic particles collected at Galveston than Mustang Island for all 3 collection times. So in the end, what do we hope to do in the future? So we did surface transects for this study, which is sampling by area, but we also plan to do future surveys where we compare sampling methods and use sediment cores to look at microplastic distribution by volume. And then furthermore, we hope to take these microplastics and use FTIR-ATR spectroscopy to determine the chemical composition of the plastics. So for example, is the plastic polypropylene, polyethylene, or polystyrene? And this could potentially give us clues as to the sources of the plastic pollution that we are finding on the beaches. So in conclusion, we found microplastics at all 3 sample sites during all of our collection times, and these microplastics do co-occur on sandy beaches where we are finding our amphipods. So I would like to thank my advisor, Dr. Mary Wixton, my committee members. I would also like to give a huge thank you to my lab mates and my undergraduate research assistants who have put in many hours helping me process samples. I would like to thank all of my funding sources and Texas Parks and Wildlife for their collaboration. Alright, so if any of you have questions, you can find me at mhayden@bio.tamu.edu. You can also find me on Facebook, Twitter, and Instagram at Maureen the Marine Biologist, and on Twitter you can find me at Maureen Marine. Remember, everyone can make a difference when it comes to lowering our amount of plastic consumption.